here we're asked to graph this function, and we started, if you remember last time, with a shape. And we know there are two different shapes for a parabola, which is, by the way, a symmetric figure. So this is the maximum and this is the minimum, and there is the axis of symmetry, which is the vertical line passing through the vertex. I'm not talking or speaking here about odd or even functions. We are only saying that whenever we graph a parabola, we have to graph its axis of symmetry. The two branches will always be symmetric with respect to that vertical line through the vertex. So in this case, the leading coefficient, so remember the general form for this situation when the square is completed, is this. So this is the leading coefficient, which is -2. So a equals -2 is a number less than 0, which makes the parabola have a maximum. In step number 2, we want to be able to determine the vertex. And here the vertex we know is h comma k. H comma k. Exactly how we determine the center of a circle. Pretty similar. Even the notation is the same. So in that case, we realize that the vertex is 1, 8. Any questions on how I got 1, 8? Please ask. Any questions? Stop me anytime. Is 1, 8 okay? Yes? Yes? Okay. Number 3, X-intercepts. And we said if they exist. X-intercepts if they exist. Okay, so we're talking about a parabola that has a maximum, and the question is, what are the options? So there are 3 possibilities here for a maximum. This is one possibility, which is the graph of the function does not touch the x-axis. The second possibility is this, which tells us that there is only one common point with the x-axis. And the third possibility is this, where we see the maximum is somewhere. It doesn't matter. I don't care about that. But there are 2 distinct x-intercepts. So the question is, which situation is this? Well, obviously here the maximum is a negative number. See, the range is between -infinity and a negative number. So this cannot be the case because we have 1, 8. So that's not. Here, the vertex will be whatever, 0, because the vertex is on the x-axis. So the maximum value of this function is 0. But that's not the case because the vertex is 1, 8. So this is the only option in which there are 2 distinct solutions. So here, we know there are 2, but the same value. But these are 2 distinct, not the same, x-intercepts. And that's the case. Because the vertex is somewhere at when x equals 1 and the maximum height is 8. So obviously the parabola has to cross the x-axis twice. This analysis is very important because I don't want to waste my time. If they don't exist, then I'll say they don't exist. If the only x-intercept is the vertex, then I'll say it's the vertex. So only in this situation I have to calculate. So how do I get the x-intercepts for any function? Yes, we have to set the function equal to 0, which is -2 x minus 1 squared plus 8 equals 0. How do I solve such an equation? What do I have to do first? What do I have to do first here to solve for x? Say it again. I will not do that because I have 4. Very good point. I have 4 possible methods to solve quadratic equations. Not all of them are applicable here, but I have 4. Factoring, taking square roots, completing the square, and a quadratic formula. So what is the very first step for this particular situation? Say it again.
Change the
Anyone else?
I was thinking subtract 8 from both sides.
Absolutely, subtract 8 from both sides. Then divide both sides by -2. And this is a typical situation, specifically kind of made for which of the 4 methods I mentioned? Indeed, thank you very much. Taking square roots. So x minus 1 equals, what do we write on the other side? Indeed, if we forget the plus or minus, then we do not get the solutions. So then x equals 1 plus or minus 2. So then we have 2 options, 1 plus 2 and 1 minus 2. The 1 plus 2 gives us, and the 1 minus 2 gives us. So -1, 0 and 3, 0 are the x-intercepts. So remember, this was step 3. So we have step 1, step 2, and now step 3. Now we have step 4. Any questions on step 3, finding the x-intercepts? Yes, please.
At what point would we want to, if at all, plug in those x-intercepts to make sure that they are actually?
You can if you want, but very good question. But the moment we start graphing it, if they are not symmetric with respect to the axis of symmetry, if this one is 2 units away from it and this one is 3 units away from it, I said, no, it's not possible. It's a symmetric curve. So if I'm the axis of symmetry and I graph something like this, I know that that's not possible. We'll immediately catch the mistakes. Very good question. Yes, Blue, sorry?
Could you graph x equals 3 and x minus, or x equals -1 either way? That's one or the other forward?
The equation has only 2 solutions. No matter how you get to the solutions, they must be the same. If mine work, you cannot find others.
Right. But I'm saying, like, could you use, like, completing the square? Or
The square is completed.
no. I'm saying, like, could you use something different other than that?
All 4 methods, yes.
Well,
They will all give you the same solution no matter what.
Okay.
But you will make your life more difficult if you use any other method but this one. This is the easiest one in this particular case because the square is already completed. Why would you expand, add, multiply, or factor and then get the solution when this is already set up so that you can simply take square roots? I'm not saying you're not going to get full credit. You're going to get absolute full credit. But it will take you 10 minutes instead of 1.
No, I just wondering, like, so. Like, if
Okay,
that's
which method? Yes,
not-
okay.
I'm saying, like, if that equation is, like, on the test, how do we know, like, which one is the best method to, like, use?
The square is completed. I mean,
Well, I'm saying, like, maybe not that particular equation, just, like, another example.
okay, so when we solve quadratic equations, we have 4 possibilities. Factoring, which not always works. And if you remember, I said, if it takes you more than 30 seconds to factor, forget it. Okay, because we have other methods. If it's the square is completed, I simplify a little bit and I take the square root. I will not do anything else. The third method, never. Complete the square, never, unless I'm forced to. And the last method is quadratic formula. I will not use the quadratic formula here, because then I have to multiply, I have to square, I have to distribute -2, I have to add 8. No. Factoring doesn't work. There is no way I should go ahead and factor. It will take me 10 minutes. There is no way I can use the quadratic formula. Absolutely, I will not complete the square because the square is already completed anyway. So my only option is taking square roots. So that's how we think when we decide which method to apply. Always try factoring. If factoring is, it takes you more than 30 seconds, forget it. Jump to the quadratic formula. In the middle, you have taken square roots, which is exactly what you should do. It's already x minus 1, everything squared. You're not going to break that. If you break that, it will take you longer to solve. And complete the square is irrelevant here. The square is already completed. But if you want to distribute and combine like terms, I can show you how to factor this, and you'll get the same solutions. You want us to do that?
Oh no, I was just wondering, like, how do I know, like, immediately, like, whenever I see that?
You only have 4 methods, basically 3.
Okay.
And this is not something you can factor. This is not something that you would use quadratic formula on, because you have to have everything on one side and set equal to 0 and coefficients. And in descending order, everything in descending order. You can't use that. So you can factor, you can use the quadratic formula, never complete the square, so your only option is exactly taking square roots. That's what I'm highly, highly, highly recommending, and I don't mind begging you, please, every weekend, find the time to print out those tests. I mean, the test 1 with 2 versions, and work on them. Because then when we finish test 2, you're going to possibly forget the material from test 1. But if you do it every weekend, it will always be fresh in your memory. So please do that. Please. Okay, so we determined the X-intercepts. Now our step number 4 is the Y-intercept. The Y-intercept is always determined how? When? Excellent. So we have to find f of 0. So let's do this together, please. How much is 0 minus 1? How much is negative 1 squared?
1.
How much is 1 times negative 2? And negative 2 plus 8 is? That's it. So 0, 6 is the Y-intercept. 5, 6, and 7 are just words, but very important words, especially for word problems that we are going to look at in a minute after we look at the other version of the quadratic function. So number 5 is the axis of symmetry. Although the axis of symmetry is not part of the graph, we have to plot. We have to plot some points, and we have to graph the axis of symmetry. So here is the vertex in our case, 1, 8. Vertex 1, 8. And we have to draw a vertical line through the vertex. Can anyone give us the equation of this line? The vertical line through the vertex. Very good. Awesome. Indeed, x equals 1. So the axis of symmetry is x equals 1. One more time, we're not talking about odd or even functions here. We're talking about the fact that the parabola is a symmetric. So this is a parabola. I don't think I wrote that. So the graph is a parabola. And the parabola has an axis of symmetry no matter where it is. So then, step number 6. Does this function have a max or a min? What did we say? Max. So then the max value of f of x is, look at the vertex and identify the maximum possible y value. Very good. Indeed. The y coordinate of the vertex. Very good. And the last thing that we have to write is the range. When we graph this with my arms up and down, we determine the range, and you can also determine the range from here, knowing that it has a maximum and the vertex is 1, 8. So what will be the range? Very good. Indeed. Negative infinity till 8. We know the range and we haven't even graphed the function. Why? Because we use transformations on this function and we know really, really everything about it. Okay, so now let's graph. We always start by graphing the vertex, plotting the vertex, and then graphing the axis of symmetry. 1, 1, 2, 3, 4, 5, 6, 7, 8. Here's the point. Then I draw the axis of symmetry. This is not part of the graph, but I have to make sure that the graph stays in shape. Because if I graph something like this, then you know that that's impossible. That would be a terrible mistake. Will my graph be perfect? Absolutely not. But at least you see the attempt of making it symmetric with respect to the axis of symmetry. So then we plot 3, 0, and then -1, 0. I have to make sure that this distance equals this distance. And then I have to graph 0, 8. No, not 0, 8. 0, 6, sorry. And now try to present the graph as symmetric as possible and not too acute the vertex. It's not the absolute value function. It's something like this, right? So as round as it's permitted. And try to make it as symmetric as possible. Is my graph perfect? Far from it. But this is -2 x minus 1 squared plus 8. Any questions? Any questions? Now let's look at the other possibility. Let's say I have -x squared minus 6x minus 9. Is this a quadratic function? Yes, it's a quadratic function. However, this one does not have the square completed. So there is a slight difference from the previous case. Okay, so the same steps from before. Number 1, what is the shape of this graph? We're analyzing, maybe I should have said that from the beginning. We're analyzing the graph, we're analyzing this function and study its properties so we can apply the model to real life situations. That's the purpose of it. But we can simply start looking at real life applications before analyzing the graph and understanding a little bit more about it. And you can say, oh, we've seen this before in transformations. True. Not this one, though. We've seen combinations and transformations on x squared, but we cannot do the same thing here unless we complete the right, and we don't want to do that. I mean, you can if you want to, but it would be extra work. Okay, so in this case, what is the shape of this graph? Does it have a minimum or does it have a maximum? Oh, we had a maximum. Let me change this. Sorry, we already had a maximum. I want you to see the other option. My apologies. Okay. So yes, it's a minimum because the leading coefficient is 1, which is a number greater than 0. In step number 2, we want to find the vertex. Well, we cannot find the vertex without some effort. We need to put in some effort. And here's the effort, but I want to talk about what happens here before I'll show you the steps. Forget about the vertex, forget about this for a moment, just 1 second. So when I have an equation like this, and I want to use the quadratic formula to solve, I will write x equals, can anyone tell us what to write?
B plus or minus the square root of b squared minus 4 times ac over 2a.
Good. So the coordinates of the vertex, I want you to memorize these two. I don't really want you to memorize, but since we are using it so much, we know it by heart. I want you to understand that these two go together. Why? Because this coordinate, the x coordinate of the vertex for such a shape, for such a situation, or version of the quadratic formula, is this. So I'm hoping that connecting these two topics and the fact that you remember the quadratic formula, you should be able to remember the x-coordinate of the vertex, negative b over 2a. Now the question is, let's find the negative b over 2a first. So negative b over 2a, negative from the formula. How much is b in the problem? Perfect. 2 times a in the problem. 2. And the answer is? Very good. So the vertex has the x-coordinate negative 3. But that's not sufficient. I can't plot a point if it only has the x-intercept. I'm sorry, the x-coordinate. So then how do I find the y-coordinate of the vertex? Careful, if I set the function equal to 0, I find the x-intercepts. So if I say to you, I have a function. So I have a function for you. I'm telling you the function is x squared plus 6x plus 9. And I'm asking you to, and I'm also giving you negative 3, x is negative 3, and I'm asking you how will you find the y-coordinate of that point. Yes?
Y equals x squared plus 6 times x plus 9.
So you are saying f of negative 3.
Yeah.
I completely agree. So this number is nothing else but f of negative 3. So therefore, this is f of negative b over 2a. Exactly it. Excellent. Thank you. So let's determine that. So I go back and plug it in, and I have f of negative 3, which is negative 3 to the second power plus 6 to negative times negative 3 and plus 9. It's very easy to make a mistake here and consider negative 3 squared as being negative 9, which is not the case. Be very careful. So negative 3 squared is 9. 6 times negative 3 is negative 18 and plus 9. And this is 9 plus 9 and minus 18. And the answer is 0. What does this mean? It means that the vertex is also what? The x-intercept, indeed. So there are no other x-intercepts. So x-intercept, yes, negative 3, 0 as well. If the vertex is on the x-axis, that is the only x-intercept. How do we know? Let's go back for a moment to these options. I know that this time it's a minimum, but the options are the same. It does not touch the x-axis. It touches in one point. It's tangent, we say, or it crosses twice. Distinct solutions. So it's not this. It's not this, but it's exactly this in the other direction. Good. So that's it. I don't have to find anything else here, but I have to find the y-intercept, and then 5, 6, and 7, like before. And then we're ready to look at word problems that use quadratic models. Okay, so how do I determine the y-intercept for any function, including this one?
Make x 0.
Very good. Very good. So f of 0, that's easy. 0, 0, 9. So this is 0, 9. Perfect. Number 5 is the axis of symmetry. Axis of symmetry is? Yes, x equals 0, the vertical line going through the vertex. I'm sorry, I looked at the wrong ordered pair right here. Sorry about that. X equals negative 3. My apologies. It made no sense. Sorry. I thought I had the vertex there, but no, that's the Y-intercept. Sorry about that. Good. That was number 5. Now number 6 and 7. 6 is the minimum. What is the minimum? Number 6. Min, because it has a minimum. Minimum value is, yes. So this is where it happens, and this is how much, right? If you remember from max min. Minimum value is 0, and we already found the range, or no, we didn't. So it has a minimum, and the minimum is at 0. So what could be the range? Yes, because that's the minimum. Yes, it has a minimum. Perfect. Yes. Okay, ready? So let's graph the function. We plot the vertex first at -3, 0. We draw the vertical line that represents the axis of symmetry. We do not have other x-intercepts, but we have a y-intercept. 1, 2, 3, 4, 5, 6, 7, 8, 9. Obviously, this is the parabola. But since I have 3 units here, I'm just going to measure 3 more on the other side and plot 1 more point to make sure that I at least try to make it symmetric. Will it be symmetric in perfect? Absolutely not. Sorry about that. That's the best I can do. But at least I attempted, and I showed you that I'm trying to show that it's symmetric. In other words, I'm not graphing something like this. As I mentioned before, that would be terrible. That's pretty much it about the quadratic function, but I would like now to look at some applications. Ready? '59. Any questions for me, please? 59 on 361. Any questions? Okay, so let's read the problem. A ball is thrown upward and outward from a height of 6 feet. The height of the ball, f of x. So I take notes. Height in feet is given to us as -0.8 x squared plus 2.4 x plus 6. And x is the ball's horizontal distance. So x horizontal distance also in feet from where it was thrown. First of all, I'm going to ask you, what type of function is this? This one? Quadratic. Does it have a max or a min? How do I know it has the max?
Negative leading coefficient.
Negative leading coefficient. So, okay. So I'm standing here. That's my starting position. And here is my ball. And I do this. Do you see what happened? Maybe about 2 feet, 3 feet away from me, it reached the maximum. You went high to the maximum and then fell on the floor. Okay? What kind of trajectory was that? Quadratic trajectory with a maximum of whatever, with a leading coefficient of -0.8. Okay, first question then. What is the maximum height of the ball, and how far from where it was thrown does this occur? Remember, I asked a couple of questions. The first question was, what type of function is it? The second question was, if it has a maximum or a minimum. And now we're trying to find the maximum. So part A, find the maximum height. So what do I have to do first? What do I have to determine first? Excellent. Great job. Good. How do I determine the vertex for such a function?
-c divided by 2x.
So I cannot jump to the y value. This is what they're asking. The maximum height is the y value. But I can determine the max value before I determine the x coordinate of the vertex that I will eventually plug it in to get this. So negative over 2a, so remember negative is from the formula. B is 2.4, and 2 times a is negative 1.6. So while I'm standing here and I throw the ball up in the air, obviously the distance between where the maximum is, the distance must be a positive number, right? Okay, so make sure you have two negatives in there, so obviously the answer will be positive. So when we divide 2.4 by 1.6, what do we get? What did you get? I got 1.5. Measurement unit, please. Yes, so this is 1.5. Now, having the x coordinate of the vertex, how do I find the y coordinate of the vertex? Exactly, f of 1.5. Very good, awesome. So f of 1.5 is negative 0.8 multiplied by 1.5 squared plus 2.4 times 1.5 and plus 6. Let's plug this function in the graphing calculator, please. So go to y equals and clear whatever you have in there. And let's punch in negative 0.8 x squared plus 2.4 x and plus 6. And I want to go to second and table and plug in 1.5. I may be interested in plugging in more numbers. I can plug in 0 and I get 6. I can plug in any number I want. But a positive number, because obviously it will reach a maximum height after some action, right? You can go back. Good, so we got to that the vertex is 1.5 comma 7.8. So I can already picture this graph. 1, 2, 3, 4, 5, 6, 7, 8. And here's 6, obviously. And at 1.5, so at 1.5, the function goes high to as high as possible, as high as 7.8, and then it will eventually hit the ground. I don't know exactly how far it will hit the ground. We'll see. Part B. How far does the ball travel horizontally before hitting the ground? Okay. So I know that it will eventually hit the ground, but I don't know how far. From where I'm standing. I'm standing here, and I'm throwing the ball up in the air. It reaches a maximum. It hits the ground eventually. So how do I determine how far away from me, from where I'm standing, will the ball hit the ground? The x-intercepts, indeed. So in part B, find x-intercepts. How do I find the x-intercepts? Oh, I forgot to put this in. Please put it in. It's 7.8. 7.8. Of course, feet. That is the maximum height. If we need to, that's how we get the maximum height. Okay, so now how do we find the x-intercepts? What do we need to do to find the x-intercepts? Yes, we have f of x equals 0, negative 0.8 x squared plus 2.4 x plus 6 equals 0. So see how all these concepts that we studied so far come into play. So yes, this is a quadratic equation. Will I try to factor? No. Will I try to complete the square? No. Can I take square roots? No. So my only chance is the quadratic formula. Of course, I'm going to multiply both sides by negative 10. You already know me quite well. I refuse to solve quadratic equations with a negative leading coefficient and decimal numbers in there. the way I write. Sometimes I may forget the decimal point, and I get something out of this world. So I multiply both sides by -10. Do you have to do that? No, but you make the equation, I mean the quadratic formula more difficult if you don't do this. So this is 8x squared minus 24x minus 60 equals 0. And can I divide by 4? Yes, I can divide by 4. So 2x squared minus 6x minus 15 equals 0. Yeah, this I like. 2, -6, and -15 are fine. And now negative b plus or minus b squared minus 4 times 2. Instead of writing -15 here, I do this over 2 times a. Why? Because I try to avoid any confusion. I try to avoid, if possible, nested parentheses. Why not? So let me repeat what I just did. So negative b plus or minus b squared, this is always positive no matter what. So please do not ever start here with a negative number. -6 squared is still 36. Minus 4 times 2, but I should have written -15. Instead of writing -15, I changed this up. Because there are 2 negatives in there that I need to multiply over 4. Now, very carefully, let's enter this into the graphing calculator. So I need parentheses around the numerator, and I need parentheses on some calculators, not all, but I'm going to put them always. Parentheses around the numerator. Now, if I have something like this, I will have to put parentheses around the denominator. Of course, don't correct anything because I'm going to change this. I'm going to erase it. So right now, because the denominator has only one factor, or I would say better, only one term, there is no need to put it in parentheses. So let's do that together. Left parenthesis, and then 6 plus the square root in parentheses, 36 plus, I can do 4 times 2, which is 8, 8 times 15, close the parenthesis under the square root, outside close the parenthesis, and then divide by 4. So now I copy with second and entry, and for you with the calculator, second and entry, it's much easier than it is for me to go back and overwrite plus in front of the square root by a minus. Of course, this makes no sense. It doesn't mean anything to us. So the two solutions are x equals 4.62 feet and x equals -1.62 feet. Algebraically, it's a correct solution, but not when it represents a distance. So this is 1.5 and 4.62. So 1.5, 2, 3, 4.62. Okay, I'm going to say somewhere here. And this will be somewhere here. But there is no need to continue that way. So this is the graph of the trajectory of the ball as I throw it up in there. Okay, let's see if there is a part C. Oh yeah, just graph the function. We did. Any questions? I know it's extremely hot. I want to tell you that the thermostat is on bottom of the bottom cold, which means the highest possible cold.
Lowest possible.
I consider it high cold. You're right, of course. Okay, would you like to look at another problem? Yes, please.
Did you graph it at 6? Isn't it supposed to be graphed at like 4.63?
4 point. So I thought it was 1.5, 2, 3, 4. Yeah, it's not accurate. But
I thought there were intervals of 1, and I was like,
no. But now look. Sorry about that. Of course, it's not perfect. My apologies. Okay, would you like to look at another problem? Yes? Okay, very good. Among all pairs of numbers whose sum is 16, So you can see a different application of quadratic models. So I'm reading from problem 61 on page 361. I know it makes us all sleepy. It's so hot. I know. Among all pairs of numbers whose sum is 16, pairs of numbers with sum 16, find a pair whose product is as large as possible. Find a pair with product max, with maximum product. Let's see how we think about that.